So in this section, we are going to be looking at the gas turbine. We are going to look at some basic principles of the operations of the gas turbine. So the gas turbine, as you well know, is a very simple machine, but rugged. In fact, all of the turbines, gas turbine, steam turbine, wind turbine, and the water hydro turbines, okay, they are all very simple but rugged equipment. So now we are going to look at the gas turbine, the various components of the gas turbine, what they do, and how these various components they actually function, their physics of operations, and how they interact with one another to produce the overall function, okay, or overall functioning of the gas turbine. So the gas turbine basically is composed of three major parts. So the first part that we are going to be looking at is the compressor. The compressor part, which is this part of this particular gas turbine that you are seeing. So the basic function of the compressor is to compress the air that is drawn into the gas turbine into the gas turbine through this intake plenum. Okay, so the compressor, its function is to compress the air. So that's the first part of the gas turbine that we will be looking at. The second part of the gas turbine is the combustor. So in the combustor, this compressed air that is generated in the compressor will be sent to the combustor. And then within the combustor, as you can see, we have fuel nozzle. That fuel nozzle, its function is to inject fuel into the compressed air, and then it is combusted. So that hot combustion product that is generated within the combustor is now sent, or will now be sent, to another section of the gas turbine, which is the turbine section, which is this area. So the hot combustion product from the combustor, okay, will now flow through into the turbine section. So the turbine section, its function, as we will see later, is basically to convert the kinetic energy that is contained in that hot combustion product, fast moving combustion product, into rotating energy. So these are the three major parts or components of the gas turbine. But for the gas turbine to function properly, or for these three components to function properly, we have other auxiliary systems or components, and that's the lubrication system. Since we have rotating parts, definitely we need to lubricate those point of contact, okay, where the rotating part, which is the rotor in this case now, have to be turning within its axis. So we need lubricants or a lubrication system to help us to reduce the friction at those contact points. Then, since it is a system that generates a lot of heat, we need to cool it down also. So we have the cooling system, and of course the fuel injection or the fuel system. So since we need to inject fuel at an appropriate ratio into the compressed air before it is combusted, we therefore need a system that will help us to monitor this and be sure that the appropriate ratio is sent into the combustion chamber. So these are the various components of the gas turbine system, simply put, that we will be looking at. So as you see on your screen, the gas turbine is a very simple mechanical machine consisting of these three major parts: the compressor, the combustor, and the turbine section. So let's dive into how each of these parts they function, or how they do what is expected of them. So let's look at the compressor now. The compressor, the basic function of the compressor is to, as we saw in our earlier training on compressors, The function of the compressor is to generate that compressed air that will be needed in other section of the gas turbine. So we have basically two types of compressors. We have the centrifugal compressors, okay, though both of them are dynamic compressors, and then we also have the axial flow compressor. So let's look at the centrifugal compressors first. So as the name implies, centrifugal, that is away from the center towards the circumference. So that is what happens in the centrifugal compressor. So what happens is that the intake air is taken into this is the impeller of the centrifugal compressor. Okay, so as it's turning, it reduces the pressure in this area, and that helps to take in or drag in more air into the turbine. So that air, as it goes into the turbine to this impeller in the compressor section, what happens is that this vein of the impeller, okay, as you can see here, helps to accelerate or increase the velocity of the air as it's coming in. So, and as it's increasing the velocity, it directs it away from the center towards the circumference, and that is what you are seeing here. Okay, creates low pressure, sucks in air, then increase its velocity and directs it away from the center towards the circumference. Then as it's directed away, the velocity of the air molecule will have been increased at this stage. As you see on your screen, the velocity will have been increased. Then as this fast moving air molecule impinges on the wall of this casing of the compressor, what will happen is that that speed will momentarily be stopped, okay, or reduced. So when you apply Bernoulli's principle, that reduction in velocity or in speed is what will now be converted to increase pressure. Okay, so Bernoulli's principle have a lot of role to play here in converting the fast moving air molecule into high pressure air molecules. Okay, so that compressed air that is generated here will now be sent to the second stage for further compression. So that is how the centrifugal compressor actually function, and it happens in the turbine also. So here you see the other parts or component of the turbine. This is the compressor section, which is two stage. Then we have the combustor. Okay, here is where the nozzle, fuel nozzle is connected. Okay, and then this is the turbine. This is the turbine section. Are we getting it? So this is the turbine section of the gas turbine. So the other kind of compressor that we will be seeing is the axial flow compressor. Remember, in the radial flow compressor or the centrifugal compressor, you see that the air is directed away from the middle towards the circumference of the impeller, okay, so that it will strike on the casing of the centrifugal compressor so as to increase, that is, reduce the speed and increase the pressure. Okay, so but in the case of the axial flow compressor, the compression is done along the axis of the shaft, as we see here. Okay, so it is done along the axis of this shaft. This is the axial flow compressor. So a combination of this is the rotor, and we have different sets of blade, okay, on the rotor. So a combination of one set of rotating blade, that is set of blade on the rotor, and one set of stationary blade, the set of blade on the stator of the gas turbine, makes up a stage. So on each stage, whatever air that is drawn into the gas turbine will be compressed, its pressure will be increased, okay, on each of these stages. So if you look at it, you'll see that the increase is done along the axis of the rotor. So what happens is that the principle is the same. This rotor blade, since it is turning, it will add velocity, okay? It will increase the velocity of the incoming air molecule. Then as it is accelerated towards the stationary blade, it is momentarily stopped, and Bernoulli's principle applied here again will convert that reduction in velocity to increase in pressure. So the pressure of the air at exiting the first stage will be higher than the pressure of the air entering that first stage. So that increased pressured air will be sent to the second stage for further pressurization, okay? So you see that at the end of the day, what will come out at the end of the compressor will be of a high pressure. So the pressure here, which is the discharge pressure, is always higher than the pressure at the middle and the pressure at the intake. So that's the axial flow compressor, and that is what we are seeing here. Okay, you see that it is compressed as you move away from the intake. This is the set of blade, stationary blade and the rotating blade. So a combination of these make a stage. This is another stage. So we have 1, 2, 3, 4, 5, 6, and 7. 7-stage compressor. So if you look, you see that there is a kind of connection to this stationary blade, okay, which means that these blades could be adjusted, their orientation could be adjusted either to close the gap between them or to expand or open the gap between them. So we'll see the function of it later. They are called the inlet guide vane, okay? So we'll see the function of the inlet guide vane as we move ahead. So this is how we'll see it physically. This is a cross-section of a cutaway view of the compressor. So this is the stationary blade, and here we have the rotating blade, okay? So this is 1, 2, 3, as much as you can see. So 3-stage of the compressor. So this is axial flow compressor. So the next component we'll be looking at is the combustor. Combustor. Now, this compressed air that has been generated in the compressor will be sent to the combustor. This is the compressor now. The compressed air that is generated here will be sent to the combustor. Okay? So within this combustor, which is this, you see that all the compressed air will come in. This is the direction of flow of the compressed air. So some will come in through the openings around this the burner, okay? While that is the injector, they inject the nozzle, okay? Then others will come in through perforations along, that is downstream the combustor, okay? So the compressed air that comes into the combustor, 30% of it, those are the ones that entered into the combustion chamber through this the opening behind the combustor, as you can see, okay? About 30% of this compressed air is used for combustion purpose. So once it is combusted, remember it will be of high thermal, energy. That is, the temperature will be very high, so it needs some level of cooling before it is sent into the turbine, or else it can destroy the turbine blade or even other components before the turbine blade itself, as we'll see later. So about 70% of the compressed air, okay, remember 30% have been used for combustion, 70% will be used for cooling. Some of those 70% will come into the combustion chamber and mix with the combustion product to cool it down, okay, to reduce its temperature before it is sent to the turbine. And then the remaining part of the 70% will also be sent into the turbine for further cooling of the turbine. So this is the combustor. So we have the fuel injector, the fuel nozzle, and then we have an igniter that ignites or starts the combustion. Okay, it produces a spark to start the combustion process within the combustion chamber. And that is what you are seeing here. Now, this is the combustor. So these are the fuel nozzle and these are the fuel lines. Okay, so coming from, if it is a gas turbine, if it is gas fire turbine, you see that this fuel line will be connected to the source of your gas. Then if it is maybe diesel or kerosene driven turbine, those or fuel oil, those lines will be connected to your source or your tank containing the fuel oil. So that is the combustor. Its function is to mix that compressed air with the right amount of fuel and ignite that mixture. Okay, so after being ignited, you see that a combustion product will be produced. That combustion product contains a lot of energy, such that the kinetic energy of all the air molecules that are within the chamber will have been multiplied multiple times. Okay, so that high energy combustion product is what will now be sent downstream your gas turbine. So we'll see that later. So this is the combustor now. So you can see the fuel injection. These are the parts of the air that comes into for combustion. Okay, so these are the primary air. Those are the ones that are used for combustion. You see that the secondary air, those that comes in for cooling, you see them coming into the combustor or combustion chamber from openings or perforations downstream the combustor as the air. So, and again, you see that this blanket of air will also help to cool the combustor as combustion is taking place within the combustor. So that is how it is designed, and that is how it functions. So the right air fuel ratio have to be maintained here so as to get the optimal operations at this stage of your gas turbine in general. Okay, so the combustion gases or the combustion product that is coming out from the combustor will now be sent downstream the gas turbine, okay, through the transition piece to your turbine, to the turbine section of the gas turbine. So here you can also see a cutaway view of the combustor. Okay, so you see that the primary air will come in through here, the secondary air will come in through all of this perforation. The others within the jacket will help to cool the combustor. Then the combustion products will now be sent, okay, to the turbine section, as you can see here. So here is it. You see the primary air coming into the combustion section, okay, through the burner, the fuel nozzle, okay. So it is burnt here, and then the secondary air mixes with it to cool it and also cool the jacket. Are we getting it? Over the combustor. So this is how you see it physically. These are the perforations or the openings into the combustors that the cooling air will go in through. So this is a cutaway view. This is the section where the secondary air flows through. This is it. Then the primary air comes in through here. Here we have the fuel nozzle or the injector, and then here we have the igniter. Okay, so all these perforations, they are for cooling air to dilute the heat content or the temperature of the combustion product within the combustor. So this is the combustor, a coupled one now. Okay, as you will see it physically. Then the combustion product, the fast moving high energy combustion product from the combustor, will now be sent through this transition piece. Are we getting it? Through this transition piece into the turbine section, as we will see later. So this is another very important piece or component of the gas turbine. So you will see that if the temperature is not properly regulated within the combustor, this transition piece could even be damaged before the hot combustion product will go to the turbine section and do further damage to your gas turbine. So this is also showing us the transition piece before it is moved into, that is, the combustion product is moved into the gas turbine section. So the next that, okay, here is also showing us the combustor. Okay, so the air that is drawn in, compressed, this is the axial flow compressor, sent into the combustion chamber, mixed with fuel, ignited, mixed with fuel at the appropriate or proper ratio. Okay, as it's leaving the combustion chamber, it will go to the turbine section to do the work for which it is designed to do. So this is showing us what we have actually discussed before: primary air, secondary air. Okay, then the combustion product sent into your turbine section. So next we are going to be looking at the turbine itself. The turbine, the basic function of the turbine is to convert the kinetic energy in that high energy combustion product, is to convert it into rotating mechanical energy. So that is what we actually want from the gas turbine, and that is what the turbine is doing. So as you can see, we have two sets of blade in each of the stages. Here we have 4 stages. Okay, so we have the stationary blade, which are the blades that are on the stator of the turbine section. Then we have the rotating blade, which are the blades on the rotating part of the gas turbine, that is of the rotor. Okay, that is the rotating part of the gas turbine now. So a set of it makes a stage of the gas turbine. So what happens is that as the hot combustion product is coming, when it impinges on this blade, this rotating blade, okay, that force will cause the blade to start turning. It's just like you directing a jet of air to the blade of a fan. What will happen is that jet of air will cause the blade to be turning. That is exactly what is happening here. Okay, so that is the impulse blade. That is, it functions by way of impulse. Then there is also the reaction part too. Remember the space between the blade, as you can see here, the space, they are so designed such that it will throttle, okay, the gas that is going between it to direct it to the other. This is the stationary blade now. Okay, this is the rotor, and then this is the stationary blade. So it will throttle it, and once it is throttled, we know that the pressure with which it is exerting, or the force, will increase. Okay, and that will create a reaction force on the blade itself and further cause it to turn better. Okay, so a combination of this impulse and reaction will make the blade to be turning, okay, helps to convert the kinetic energy in the combustion product into rotating mechanical energy. So that is exactly what is happening here. This is on the rotor, this is the stator. The jet of air that comes in directed and it impinges on this, directed towards the rotor blades, impinges on the blade, force them to turn. Okay, then reaction force too will also help to increase the speed at which the turbine rotor is turning. So that is how basically the turbine converts the rotating mechanical energy, converts the chemical energy that is contained in the fuel to rotating mechanical energy. So by way of recap, because the gas turbine is also like the internal combustion engine or the four stroke engine. So simply put, that is how the gas turbine work, and that is what you are seeing here. The intake air is compressed, sent to the combustor, ignited, and the hot combustion product is sent as it's flowing through the turbine section, causes the rotor to turn since the fast moving combustion product molecules is impinging or striking on all of this blade. The rotation of the blade will cause it to turn to a particular direction. So the weak combustion product, okay, that is the combustion product that you have extracted energy from, will now be exhausted. So that also contains some amount of energy that could be used in your energy recovery or heat recovery section. Are we getting it? So you can send it through heat exchangers to boil, to generate steam that could be used in anywhere or any part of your process. Okay, to generate steam or to generate heat that could be used to heat up any part of your process. So this is also a gas turbine, but this is it functions the same way. We have the same components: the compressor, the combustor, and the turbine section. But in this, you will see that the turbine, okay, the power turbine the turbine is not connected mechanically. Are we getting it? There is a separation. The shaft is not continuous. Okay, so these two turbines, they are aerodynamically coupled, because the hot combustion product that is coming from this stage, this one is meant to generate to turn the compressor to generate the compressed air that we need. And then this is the power turbine that will now generate the rotating mechanical energy that we will need for our load, either to drive other mechanical equipment, to drive generators, to drive compressors, to drive pumps. Okay, so this shaft is coupled to your load or to your gearbox before your load. Okay, so this is the power turbine. Does not have any connection here, so they are aerodynamically coupled, so to say. Why it is said so is because the hot combustion product that is coming through, okay, these two sets will convert some of those kinetic energy contained in them into rotating mechanical energy that will drive the compressor, and then the remainder, as it's going through, will turn this turbine. So this one is moving irrespective of this set. So that is the aeroderivative turbine. The two turbines, they are aerodynamically coupled. They don't have any mechanical connection. That is what you are seeing here. This is the turbine section. Okay, so they are not having any mechanical connection, but aerodynamically they are coupled, because as the hot gas is moving through, it's turning this and it's also turning this. Okay, so that is what you are seeing here now. So the air is intake into the intake plenum, compressed in the compressor, sent into the combustor, and then combustion takes place. Okay, sent into the combustor, combustion takes place. The hot combustion product is directed into the turbine section. So you see, this part is not connected to this part. This part produces the energy that is needed to turn the compressor, while this, the power turbine, produces the energy that your load, okay, needs, that will turn your load. So both of them, they are aerodynamically coupled, no physical connection. So that is what you are also seeing here. Okay, so we need this power to drive our load, this rotating mechanical energy to drive our load. So this is the fully coupled turbine, gas turbine. Okay, so here, this is the starter module. So we have the intake plenum, okay, and then we have the exhaust plenum. Okay, so that's your load that is there. Then this is the starter motor to actually turn the equipment during startup.